Hi everyone, welcome to the first lesson in our organic chemistry series. In this lesson we're going to be exploring the simplest building blocks of organic chemistry, which are the alkanes. But before we get there, let's ask a big question. What is organic chemistry? Well, simple question. Organic chemistry really is just a branch of chemistry that focuses on carbon-based compounds. Carbon is unique because it can form 4 bonds due to its 4 valence electrons. And it can connect to other carbons to form chains, rings, and complex structures. That's why studying carbon is so important. Almost everything in living organisms, fuels, and even plastics is built from carbon. So when we talk about organic chemistry, we're really talking about the chemistry of carbon's versatility. Let's start off with what hydrocarbons are. The simplest type of carbon compounds are called hydrocarbons, which are made of only carbon and hydrogen. I bet you could have guessed that, huh? Hydrocarbons can be classified into different types, though, based on the bonds they have. Today, we're starting with the most basic, which are the alkanes. Alkanes are hydrocarbons that contain only single bonds. Very important. They only contain single bonds. Because all their bonds are single, we say that alkanes are saturated. This might not be really important right now, but I really want you to learn. Please memorize this. Alkanes are saturated. We say they're saturated because they're saturated with hydrogen, meaning each carbon has as many hydrogens as it can possibly hold. This is in regard to the capability of carbon to form 4 different bonds, and since alkanes only form carbon-to-carbon single bonds, that means that the rest of the bonds can be for hydrogen. So it is saturated with hydrogen. Now, let's draw some alkanes, shall we? I already drew them to save time on this lesson, but here are the first 4 alkanes I want to introduce you guys to. We have methane, ethane, propane, and butane. Methane has the formula CH4 because it has a singular carbon, and we know carbon can form 4 bonds, so it's going to be bonded to 4 different hydrogens. Now let's move on to ethane, where we have 2 different carbons. They're single bonded, as you can tell, and since these carbons are single bonded to one another, that means they have 3 free bonds to still form, so they bond to hydrogen. So we have 1, 2, 3, 4, 5, 6 hydrogens. As you can see, there's still no internal carbon, meaning there's no carbon in between like the outer carbons. So the outer carbons are capable of forming 3 bonds with hydrogens, because they only form 1 bond with the internal carbon, but we'll get to that when you see propane. Propane has 3 carbons. They're all single bonded, as you can see, and now we finally have an internal carbon. An internal carbon is bonded to 2 different carbons, as you can see right here and here, so it can only have 2 more bonds, equating to a total of 4 bonds. So the other 2 bonds will be with hydrogen. So as you can see, internal carbons can bond with 2 hydrogens, whereas these outer carbons, since they're only bonded to 1 carbon here, which are the internal carbons, the outer carbons actually have 3 free bonds, so they bond with 3 different hydrogens. So this is internal carbon, whereas the outer carbon bonds with 3 hydrogens. Let's move on to butane. Butane has 4 carbons, 1, 2, 3, 4, and they're all single bonded. As you can see, there's 2 different internal carbons and our 2 outer carbons. Without counting the carbons, because I'm going to introduce you to a formula to calculate the hydrogens based off the amount of carbons, let's use this we learned right here, where internal carbons are bonded to 2 hydrogens because the other 2 bonds they have are with carbon, and outer carbons can bond with 3 hydrogens because their only other bond is with an internal carbon. So if we can see that there's 2 internal carbons then that means if each of those can form 2 bonds with hydrogen, and there's 2 carbons, that means there's 4 hydrogens they're bonded to. For the outer carbons, each of them is bonded to 3 hydrogens. If you add this up, we get a total of 10 carbons. There we go. So, introduction to the alkanes formula. We have CNH2n plus 2, where n is the number of carbons. So, let's say we have butane, for example. In this case, our n would be 4, so we would have C4. And then if we plug in 4 into the H2n plus 2 formula, we would get 2 times 4 plus 2, which is 8 plus 2, which is then 10. So we would get C4H10. So this formula always works for any saturated alkane, meaning maximum number of hydrogens, and that's because all the carbons would be single bonded to one another. Now, why is there a plus 2 here? That plus 2 comes from the fact that the outer carbons, which are these right here, are only bonded to one single carbon, and as a result they have an extra bond to spare, which they happen to bond with hydrogen. So that's where that extra plus 2 comes from. It comes from the outer carbons. What about the 2n? Well, if each internal carbon, which are these, are bonded to 2 other carbons, well then that means they still have 2 more bonds, right? So they use those 2 bonds to bond with hydrogens, as seen here. And that's true even with the outer carbons, as you can see. They're always bonded to 2 hydrogens. So in a saturated alkane, a carbon will always be bonded to at least 2 hydrogens, with the exception of the outer carbons, which will be bonded to an extra hydrogen. So that's where the plus 2 comes from. For right now, don't try to drill this into your head, but keep it in mind as it will be useful when we get into our second lesson. Now, let's talk about alkane properties such as boiling points. Boiling point is the temperature or kinetic energy at which a liquid can turn into a gas. For alkanes, the larger the molecule, the higher the boiling point. Why is that? Well, it's because larger molecules have more atoms and electrons, which leads to stronger intermolecular attractions, specifically London dispersion forces. We can ignore all other forces because we're dealing with hydrocarbons, nonpolar compounds. As a result, we will only be talking about London dispersion forces, which are weak forces that act between all molecules, and they increase as molecules get bigger and their surface area gets larger. So, for example, methane boils at about negative 161 Celsius, which is really cold, and it's already a gas, whereas decane boils at 174 Celsius with 10 carbons. So, as you can see, the difference is astounding by over 300 Celsius, and that's only with a 10 carbon difference. So, takeaway is that more carbons leads to more surface area, which leads to stronger intermolecular attractions, which means that the molecules will need more energy to boil. I also want to say that you guys will need to memorize these 10 prefixes: methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. I will say that from pentane to decane, it should be pretty easy, as the prefix kind of correlates to the number of carbons. That's really important. The prefix will indicate the number of carbons, and this is important because the U.S. National Chemistry Olympiad will primarily be testing you on nomenclature, and these 10 prefixes are pretty much the basis of all of that. I will say try to memorize the first 4, as they don't really correlate that well with the number of carbons. I just use mnemonics, and there's this song that you guys can search up on Instagram. It's really catchy, and that's how I memorize them personally. But yeah, you guys need to memorize the prefixes. Don't worry about the ending part so much, like the ane. As you can see, we're talking about alkanes. So of course the prefix will end in ane, but once we get to double bonds and triple bonded hydrocarbons, that ending part will change. So I really want you to know the prefix. So, recap. Organic chemistry is the study of carbon-based compounds. Alkanes are the simplest hydrocarbons with the only single bonds, and the formula CN(H₂ₙ + 2). And boiling points increase with the size of the alkane because larger molecules have stronger intermolecular forces. In the next lesson, we'll talk about saturation, cycloalkanes, and degrees of unsaturation, where we'll see what happens when molecules aren't fully filled with hydrogens. That's it. Thank you.